Hello everyone, welcome back to another semiconductors tutorial video. Today we're doing exercise 5.37 from our book Semiconductors. So the question says a constant electric field of E equals 12 volts over centimeters exists in the x direction of an n-type gallium arsen semiconductor with a size of from 0 to 50 micrometers. The total current density is a constant and is equal to 100 amperes over centimeter cubic. So the total is a drift current density and a differential current density. And it says that at x, when x equals 0, both the drift current density is equal to the differential current density. So at 300 Kelvin and at a mu of the n-type semiconductor with of 8,000 cubic square centimeters over volt seconds. And it says determine the expressions for the electron concentration. So the electron concentration is going to be Nx. Calculate the electron concentrations at x equals 0 and at x equals 50. So we need to find the expression of the electron concentration. This is expression which we know that it's equal to A plus B exponential with minus x and a d, where A, B, and D are constants that we have to get from our exercise, and x is just the distance the density is going through. The V says, okay, calculate the electron concentration at n equals 0 and at n equals 50 micrometers. So you just have to substitute here. And then calculate the drift and the differential current density when x equals 50. When x equals 50. So I already said that the total current density equals a current density of a drift and a current density of a differential, where the drift is equal to E, the electron, which is okay, so E is equal 1.6 times 10 to the minus 19 electron volts. Mu n is equal 8,000. We already know it, so we got this. We got this one. We got this one. N is going to be our expression. We do not have that. E is going to be our constant of an electric field. And then again, E is going to be the electron. Dn, we can have it from here. So they gave us T, which is 300 Kelvin, K, which is a constant, and E, and well, this is equals to this constant already. It's kind of a thing we use. So if we get 8,000 over here, so if we say that dN is equal to 0.0269 over 8,000, this is equal to 207.2. Yeah, that's the end. So we're gonna have all our values here now. So this equation is going to be over here. Let me change colors. So J, total drift is equal to 1.6 times 10 to the minus 19 times 8,000 times 12 times nx plus again 1.6 times 10 to the minus 19 times 207.2, and then the derivative of nx. So we put that in our calculator. We have that. Let's substitute this. Is this one? So we have that 100 ampere over centimeter is equal to 1.53 times 10 to minus 14 nx plus 3.31 times 10 to the minus 17 dn dx. So dn dx, we can get it from over here. So dn dx would be minus b over d, the derivative, times the exponential of minus x d. Yes, so we have two missing, which is one missing now. So first we're gonna get a. So as we can tell, x here depends. Okay, if we're gonna start off when x is equal to 0. So if x is equal to 0, let's put this here. And if it equals 0, it's just gonna be 1. So we're not gonna have that. And over here, so let's write it. Alright, 100 equals 1.53 times 10 to the minus 14 times a plus b exponential minus xd. Yeah. But since x is equal to 0, we do not care. No. We're saying that this is a constant. We have a value here already. We have a value here. So we cannot have a variable, this. So since all of this depends on that variable, we're just gonna not care about it. So it turns out that a is equal to 100 over 1.53 times 10 to the minus 14. We got a 1 here. And this is equal to 6.53 times 10 to the 15. That's a already. We got a. So with a and with that out of our way, we now we're gonna use the x equals. But so this is a kind of tricky part. We already have a constant. We know that this is 100. We have another constant here, so we cannot be depending on another variable. That's why we do not care about that. So we got a here. Now we need to get b and d. To get b and d, we're gonna go over here. So this is the first step. Oh, this is the second step. To get v, we're gonna say. So the problem said that when x is equals 0, j drift and j diff are the same. So we can say that this is 50 and this is 50. So 50 is equal to 1.53 times 10 to the minus 14 times 6.53 times 10 to the 15 plus b exponential of minus xd. That's our first, yeah, this is A. And now B is going to be, now this 3.31 times 10 to the minus 17 times the dnx, the derivative of n, which is this. Oh, I forgot here to put the. So we're gonna put times minus b my d exponential of minus x d. So this occurs when x is equal to 0. So this is going to be 0. This is going to be 0. And if we put a system of equations, we have two equations. We have one variable, two variables, one variable, second variable. So we put it on our textbooks or on our calculator. We have that b is equal to minus 3.26 times 10 to the 15, and d is equal to 2.15 times 10 to 3. Yes. So that's so for A, we now can substitute this. So A is 6.53 times 10 to 15, and B minus 3.26 times 10 to 15, and D is 2.15 times 10 to the minus 3. So now for B, we have to substitute with this at n equals 0 and at n equals 50. So this is pure calculator, and we have that this is equal to, so at n equals 50, at n0 we have 3.26 times 10 to 15 centimeters minus 3, and at n equals 50 we have that is 6.19 times 10 to the 19 to minus 15, sorry. So at C, so that's B already. It's asking us to get the expression of the electron concentration at when x is equal to 0, when x is equal to 50. Okay, so here you just have to notice that this is in meters. So this is 50 times 10 to minus 6 meters. But we're on centimeters, so it's going to be minus 4. Just centimeters. Just be careful there. Yep. And for C, the J drift, where you're going to have this with N, with NX. And X is going to be 6.19. Is it this at 50? Yes. So we're gonna grab this value and we're gonna place it over here. And that's gonna give us the J drift is equal to 1.53 times 10 to the minus 14 times 6.19 times 10 to the 15, right? This gives us a value of 94.708 over centimeter. And that's the drift but then it's 100. So to get the diff, we have that it's 100 is equal to 94.707 minus plus J diff. It's the differential. So J diff is going to be 100 minus 94.707. That's J diff, and that is equal to 5.303, right? Okay, 293. Same 293. Amperes over centimeter cube. And well, that's it. If you have any doubts, comment below. It's an easy exercise. You just have to do some math. Thank you.